Voyager 1's mysterious signals and philosophical implications. Voyager 1 spacecraft, artist concept, gliding through interstellar space. This venerable probe, launched in 1977, became the first human-made object to enter interstellar space. Today it is over 14 billion miles, over 150 astronomical units, from Earth and still sending back data. In recent months, a sensational narrative has emerged. Claims that Voyager 1 made an uncommanded course change and detected a mysterious low-frequency hum in the void. As a physicist, I must sift fact from hype. The official records show only well-understood engineering events and natural phenomena, yet the speculation they inspire touches on deeper themes of consciousness, the cosmos, and even cosmic horror. This monologue examines the evidence, weighing conventional explanations against more speculative possibilities, and reflects on what such anomalies could, or could not, mean for our scientific worldview. Voyager 1, a journey into the void. Voyager 1's odyssey is well documented. After slingshots past Jupiter and Saturn, it crossed the heliopause into the interstellar medium in 2012. Since then, its instruments have routinely probed the environment beyond our sun's bubble. For example, scientists reported in 2021 that Voyager 1's plasma wave receiver detected a faint but steady hum, a narrowband, quasi-monochromatic tone caused by naturally occurring vibrations in the sparse interstellar gas. This hum is extremely weak background noise, so weak that humans could not hear it unaided, and varies only slightly over time. In short, the mysterious hum has an established scientific explanation. It is simply persistent interstellar plasma waves, a form of ambient space weather. Voyager 1 itself continued operating as expected. As of mid-2022, it was 14.5 billion miles from Earth, with signals taking over 40 hours round trip. The spacecraft is aging, over 45 years old, and in a novel high radiation environment, but engineering teams have kept it working by clever fixes. For instance, in 2017 scientists detected degradation in Voyager's primary thrusters and successfully switched to backup thrusters that had lain dormant since the 1980s. Similarly, in 2025 engineers revived a set of roll thrusters and heaters that had been off since 2004 by flipping a mispositioned switch in the heater circuit. These actions were planned maintenance to extend the mission and had nothing to do with any exotic external influence. The alleged anomaly. Rumors versus data. The anomalous story unfolded in late 2023 and early 2024, largely via social media and third-party blogs. It claimed that Voyager 1 suddenly changed its course in interstellar space without any Earth command, and that this event was accompanied by an impossible, rhythmic hum in the telemetry. Some versions even suggest the spacecraft turned around to head back toward the inner solar system. It is important to emphasize, no such maneuver is recorded in the official data. According to NASA's Jet Propulsion Laboratory, JPL, what really happened is much more mundane. On November 14, 2023, Voyager 1 did stop sending normal science and engineering data, but this was due to an internal computer glitch, not a propulsion event. As mission controllers noted, the spacecraft was still receiving and executing commands, and otherwise operating normally. Crucially, the attitude control system, which keeps Voyager pointed at Earth, remained engaged. The downlink signal did not weaken or wander off target, indicating that Voyager's high-gain antenna stayed oriented toward Earth the whole time. In short, Voyager did not suddenly steer itself somewhere else. It simply went silent on science data due to a data system failure. By March to April 2024, the engineering team diagnosed the fault as a bad memory chip in the Flight Data Subsystem, FDS. Unable to repair the chip, they reprogrammed around it, dividing critical code into fragments and storing them in working memory locations. In mid-April 2024, the spacecraft finally responded with valid telemetry again, confirming the fix. This took approximately 22.5 hours each way to communicate. At every step, NASA's communications showed that Voyager's attitude was stable and no new thruster firings were occurring. Thus, the official timeline is clear. November 14, 2023, Voyager 1's FDS memory malfunctioned. Science data stream went silent. November 2023 to March 2024, ground engineers diagnosed the problem, affected one of 3 FDS computers. April 18 to 20, 2024. Engineers uplinked code workarounds. On April 20, Voyager resumed sending engineering status data. May 2025. JPL reactivated long unused roll thrusters and heaters by fixing a flipped power switch as a precaution before a scheduled antenna downtime. There is no entry in this sequence that involves any uncommanded course change. Indeed, as NASA confirms, the probe was operating normally, aside from the data glitch, and still receiving commands the whole time. Claims of an autonomous maneuver appear to stem from misinterpretations of these technical bulletins or deliberately sensationalized accounts. For example, one reposted story described a poke command in early March 2024 that allegedly caused an immediate stream of data. In reality, NASA's own log credits the recovery to the more complex April data repackaging process. Similarly, the reported low-frequency hum in Voyager's signal has a prosaic origin. It is not a hidden alien beacon but the natural plasma wave noise already measured and published by scientists. The sensational stories often characterize it as a coded message or mathematical pattern, but in fact the peer-reviewed study describes it simply as persistent plasma oscillations. As one researcher put it, if we could hear it, it would sound like a single steady note, essentially white noise at one frequency. All signs point to this hum being a benign physical phenomenon, not an intentional signal. Summary of official findings and timelines. Voyager 1's halted data return, November 2023, was due to a flight data system error, not any maneuver. Throughout the anomaly, Voyager remained contactable and on course, its antenna stayed earthward. The intermittent hum had been identified by NASA as plasma waves years earlier. Recent thruster and heater activations, 2025, were part of routine maintenance, not responses to an external influence. No peer-reviewed source or official NASA log corroborates an autonomous course reversal. In fact, any real change in trajectory would be impossible to conceal. It would alter Doppler shifts, signal strength, and telemetry in obvious ways. By all credible accounts, Voyager 1 continues on its predetermined path and remains the silent ambassador of Earth in the interstellar depths. Conventional explanations. From a conservative engineering perspective, nothing here defies physics or logic. Voyager is far from indestructible. At nearly 46 years old, it has suffered wear and cosmic weariness. A cosmic ray particle striking onboard electronics can flip a memory bit, as NASA explicitly considers for this case. Such single-event upsets are well known in deep space probes, and even satellites orbiting Earth. Indeed, Voyager's team has recovered from bit flips before. The 2023 anomaly fits this pattern. A few bits of code got scrambled, the gibberish output engineers saw, and fixing it required creative reallocation of data. Likewise, thruster and heater subsystems in Voyager have failed and been resurrected multiple times. The 2025 troubleshooting found that a heater circuit switch had been flipped, effectively disabling certain thrusters until engineers reversed it. This unexpected change or disturbance in the heater circuit was an internal fault, not an external agent. Such glitches are precisely the sorts of problems one expects after decades in interstellar space. By contrast, a genuine course change would require propellant firing maneuvers beyond what Voyager has ever done autonomously. On the plasma front, physicists have predicted background noise in space for over a century. Voyager's plasma wave instrument is essentially a high-tech ear, and what it hears is the static of interstellar ions ringing at their natural frequency. This is analogous to how a radio-tuned off station might pick up a faint buzz. It's real, but not an intelligible message. In short, the reported anomalies align with hardware faults plus known space phenomena, without invoking any new physics. Key physical, technical points. Aging hardware. Voyager's 45-year-old electronics are susceptible to glitches and bit flips. Engineers anticipated this and built in redundancy. Thruster systems. Both spacecraft carry backup thruster sets. Voyager 1's primary roll thrusters went offline in 2004, but were reactivated by rewiring in 2025. This was scheduled engineering, not an uncommanded impulse. Plasma waves. The hum has been identified as a very weak narrowband plasma oscillation in the interstellar medium. It is the expected background noise of space. Antenna lock. No telemetry indicates the antenna ever spun away. In fact, Voyager's signal strength stayed constant, indicating it never lost lock on Earth. Given these facts, the most parsimonious conclusion is that there is no inexplicable force at work. Instead, routine spacecraft maintenance and natural interstellar physics fully account for the observations. If anything, this episode highlights the reliability of NASA's engineering teams in wringing life out of ancient machines. Speculative hypotheses. Nevertheless, as both scientist and storyteller, I indulge the what-if scenarios. If one imagines for a moment that the anomalies were real and not just errors or noise, what could they signify? Here are a few speculative possibilities, for which there is currently no hard evidence, but which often arise in popular discourse. Alien contact. Perhaps the hum is a deliberate signal from extraterrestrials, and Voyager's slight reorientation was the craft responding, or being guided. This would be a kind of first contact via a gold record gone haywire. SETI researchers have searched for ET messages, but so far nothing convincing has come. If true, it would mean we are not alone and other civilizations exist within reach. On the practical side, any such interference would almost certainly leave more detectable traces, and all mainstream sources agree none have been seen. Cosmic intelligence or panpsychism. Some philosophical traditions, and even a few scientists, entertain the idea of a universal consciousness or cosmic mind. In this view, all matter might possess some sliver of awareness, a notion called panpsychism. If the universe itself is, in a sense, conscious, could it emit a heartbeat? The hum in this scenario would be the universe murmuring to itself. Ancient philosophies have broached ideas like the music of the spheres or Brahman's omnipresence. Modern panpsychism similarly suggests consciousness is fundamental. Voyager picking up a hum might be seen as evidence of such a monistic reality. It must be said, however, that the majority of physicists treat consciousness as emergent, and panpsychism remains a fringe hypothesis. Simulation glitch. Another radical notion is that reality is a grand simulation. Philosopher Nick Bostrom famously argued that sufficiently advanced civilizations could run billions of ancestor simulations, making it statistically likely we are in one. In that framework, Voyager's odd behavior could be a glitch in the simulation. Perhaps someone nudged the spacecraft or toggled a variable. Admittedly, most scientists find the simulation hypothesis implausible on energy grounds. Recent estimates suggest simulating an entire universe would require absurd amounts of power. Nonetheless, the idea tantalizes the imagination, and some technologists warn that we should not completely discount it. If true, what we call physical laws could be rules in a computer program, and Voyager might just be a piece of code behaving oddly. Artificial intelligence influence. One could fantasize that an advanced AI, either alien or our own distant future tech, has taken an interest in Voyager and is sending commands or hijacking data. This touches on deep questions of AI and consciousness. Neuroscientists like Anil Seth emphasize that intelligence is not the same as consciousness. A hyper-intelligent machine mind might process data at unimaginable speeds, but it need not feel anything. If an AI were behind the hum, it could simply be a byproduct of its operation rather than a meaningful message. In any event, there is no sign of any AI takeover. Voyager's autopilot is simple and inert, and none of the signal peculiarities resemble the hand of a machine learning agent. Psychological, social factors. Finally, it's worth noting that humans are pattern-seeking creatures. The internet age has shown how easily doubts and rumors can spread. The very notion of an anomalous Voyager signal may be more reflective of our collective hopes and fears than of external reality. Sometimes a story is just a story, a self-fulfilling myth picked up by conspiracy channels. As the JPL engineer Suzanne Dodd put it in a similar context, without data we don't know where the bit flip is, and we lose communication with the spacecraft, a situation ripe for misinterpretation. None of these speculative ideas demand being taken on faith, but they are intriguing exercises. In particular, the alien contact hypothesis would satisfy our deep curiosity but would overturn much of science at a stroke. Panpsychism and simulation scenarios are more philosophical, prompting us to question the nature of reality itself. All of them, however, share a common theme of cosmic horror and wonder. The fear or awe that we might be at the mercy of vast unknown intelligences, or that our universe contains mysteries beyond human ken. These themes have been explored by thinkers from Lovecraft to modern physicists alike, e.g. the dread of encountering inscrutable cosmic forces. If Voyager truly had picked up something inexplicable, it would rightly provoke existential terror as much as excitement. Cosmic and philosophical implications. Whether the anomaly is real or imagined, its meaning is worth pondering. Isolation versus connection. Our prevailing picture of the universe is one of loneliness. Earth is a pale blue dot adrift in a silent cosmic sea. A confirmed signal would shatter that solitude, implying we share the cosmos with others, intelligent or otherwise. Even entertaining that possibility forces us to reflect on the Copernican idea that we are not central. If Voyager hears a hum, we must ask, who, or what, is the orchestra, and are we part of the performance? Epistemological limits. This case highlights how thin our window on the universe can be. Voyager 1's single antenna, its aging instruments, and one-way light travel of approximately 22 hours make it a very blunt sensor. If we can miss obvious anomalies, or mistake noise for signal, it means our models might be incomplete. Scientists must remain humble and open to surprises, yet always grounded by evidence. The strongest lesson is that extraordinary claims, like an uncommanded space maneuver, require extraordinary proof. In absence of new data, we cannot overhaul our understanding of physics or cosmology just yet. Consciousness and reality. As noted, theories like panpsychism invite us to reconsider the mind-matter relationship. The anomaly rumors touch on age-old questions. Is consciousness a cosmic fundamental or a fluke of biology? If by some miracle Voyager detected consciousness out there, it would revolutionize neuroscience and philosophy. Yet even here skeptics point out that intelligence is not the same as consciousness. A truly mind-boggling outcome would not only identify alien life, but raise the question, do these other minds experience the universe as we do, or are they utterly alien? Meaning and narrative. Finally, as humans we crave stories. An unexplained signal in the black void is a story that resonates, whether it's a cosmic lullaby or a siren's song. It evokes the sublime and the terrifying. Scientifically, it prompts us to test our models and improve our instruments. Philosophically, it reminds us of the vast unknown that surrounds us. Even if the reality proves mundanely terrestrial, spacecraft electronics and plasma physics, the dialogue it started has been valuable. It has people asking what we truly know about the universe, and how we react when faced with the possibility of the truly unknown. In conclusion, Voyager 1's actual behavior remains well within the expectations of physics and engineering. No confirmed, impossible, course changes or deliberate cosmic messages. What we do here, a weak hum of plasma waves, is scientifically fascinating but far from sensational. Yet the rumors themselves force us to confront philosophical frontiers. They encourage rigor, to avoid being fooled, and imagination, to ask what if. As Voyager sails onward, our small probe may not alter its trajectory, but it has certainly steered our thoughts toward the edge of the known, a frontier where science meets speculation, and where even silence can sound mysterious. Key takeaways. Voyager 1's recent anomalies are best explained by hardware and plasma effects. NASA's logs show no evidence of an uncommanded turn, only a data glitch in the flight computer. The persistent hum is identified as interstellar plasma noise. Speculation, aliens, simulation, cosmic mind, invites reflection but lacks empirical support. Regardless of the outcome, these events challenge us to examine our assumptions about isolation, consciousness, and the nature of reality. Sources. Official NASA, JPL mission updates and peer-reviewed studies provide the factual baseline. Speculative ideas are drawn from broader scientific and philosophical literature. The reader is encouraged to weigh the evidence carefully, noting that current data do not require exotic explanations.